So another problem from chapter 7, system of particles and rotational motion. The question is to find the center of mass. This question is actually exercise question 7.16, and the question it is given: from a uniform disk of radius r, another disk of radius r by 2 has been removed. What is the center of mass of the remaining portion? That is the question. So as per the question, there is a uniform disk of radius r. From that, another disk of radius r by 2 is being removed. We have to find the center of mass of this remaining portion, that is this disk with the hole, or the center of mass of the shaded portion. That is what we need to find. So for that, first we will be assuming the center of mass of the circle with the center at the origin. Center of mass of this circle with the center at the origin, which will be at this point O itself, at the center. It will be at O itself. Okay, now I am going to consider this as a two particle system. That is, one particle will be the circle with a hole, that is the first particle, and second particle is the particle which is being removed. Okay, so for the two particle system, we have the equation, center of mass equation. So we have center of mass equation of the two particle system as m1x1 plus m2x2 divided by m1 plus m2. Okay, now here in this problem, the center of mass of this two particle system, when both of them are put together, it will be lying at the origin. So I can equate this to be as 0, and the denominator, sum of the masses can never be 0. So I can equate the numerator to be as 0. So when I equate the numerator to be as 0, I will get it as m1x1 plus m2x2 is equal to 0. Here I need to find x1. x1 is the center of mass of this portion with the hole. So x1 is equal to minus m2x2 divided by m1. Now I am going to find what is x2. From the geometry of the figure, for the circle, the center of mass will remain at the center, and for this diagram, it is at a distance of r by 2 towards the left of the origin. So I can write x2. From the geometry of the figure, I will get x2 is equal to minus r by 2. Now what I need to find is the ratio of both the masses, m2 by m1. m2 by m1. So in order to find the ratio of masses, mass is actually density into volume. Since both these particles, particle 1 and 2, both are the part of the same disk, circular disk, density of the both particles will remain the same. So I can write density into volume of the second particle divided by density into volume of the first particle. Both densities will get cancelled. So we have a ratio of volume. So volume is actually thickness into area. For a circular disk, volume is thickness into area of the second particle, and volume of the first particle will be thickness into area of the first particle. And here both the thickness remains the same because both are the part of the same disk. So both will be having the same thickness. So thickness will get cancelled. Now what we have is area of the second particle by area of the first particle. Now area of the second particle is, I'll get it as pi r by 2 the whole square divided by area of the first particle is the bigger area minus the smaller area. So it will be pi r square minus pi r by 2 the whole square. So when you simplify, you will get it as divided by, so it will be 4 pi r square minus pi r square by 4. So when you simplify, you will get it to be 1 by 3. So I will get the ratio m2 by m1. m2 by m1 is equal to 1 by 3. Okay, so now we have to substitute in this equation. in this x1 equation. So when you substitute, you will get x1 is equal to minus m2 by m1. m2 by m1 is 1 by 3 into x2. x2 is minus r by 2. So I will get the value of x1 as r by 6. That is the answer. That means the center of mass of the particle with a hole lies at a distance of r by 6 towards the right of this origin. Okay, so that is the answer for this problem.